Hello, Mayfield. It is Thursday, September 18th, and this is the weekly video for my pre-algebra students. We had our first quiz, which you received back today. Amazing. Well done. Very proud of you and your adaptation to middle school in this first month. Let's keep up the great work together. Reminder, homework is always due on Friday, which sounds far away until it's Thursday, and then that means the homework is due tomorrow. And this is our homework front and back, and I designed it so if you wanted to do it earlier in the week, it would have been a good way to also review for the quiz. I did go to the shoebox, and it said rigid transformations, which took me a while to decipher, but I believe this person is talking about the question at the bottom, because I see these directions that say use what you know about rigid transformations. So I'm going to assume this is the problem you meant, and let's look at it together. Here is a diagram showing triangle ABC and some transformations of the triangle. On the left side of the triangle, or the diagram, triangle ABC has been reflected over line AC to form quadrilateral ABCD. On the right side, triangle ABC has been rotated 180 degrees around your midpoint M to form quadrilateral ABCE. Use what you know about rigid transformations, side lengths, and angle measures. Label as many side lengths and angle measures as you can in these quadrilaterals. So this is a great problem because it does show how a reflection and a rotation aren't necessarily the same. You can see just looking at these quadrilaterals that there are some differences right away. So let's start by labeling our initial triangle, and I'm going to again make sure my tracing paper is lined up at a nice 90-degree angle at the top of the page. Here's my A, B, and C, and I have this angle, and I have this side, which is 2 2/10, and then I have this side, which is 2 7/10, and then I have this side, which is 3 2/10. All right, so the first thing I'm going to do is I'm going to reflect. Boom. And when we reflect, make sure we also line up. Okay, so what does that mean? That means that this side here is congruent to the top here. So if this is 2 7/10, this is also 2 7/10. And if this bottom of the triangle is 3 2/10 and I reflect, then this is also 3 2/10. And then I have this angle B. Let's see where that goes when I reflect it. When I reflect angle B, oh, here it is. So that means that this angle is 64 3/10 degrees. That's my reflection over side AC. Okay, now same triangle, same measurements, same initial situation, but a different rigid transformation. Now I'm going to rotate 180 degrees, clockwise, counterclockwise. Why does it not matter? Tell someone at home. Rotate 180 degrees, and ooh, look what's going to happen now. Look at that side. That's my 2 7/10. So now 2 7/10 is down here. So side EC is congruent to side AB. And let me go back and do my rigid transformation again. I'm going to rotate 180 degrees the opposite direction this time, and I'm still right. Oh, and look at the top now. That's my 3 2/10. So side AE is congruent to side BC. And then can I also find my angle that is congruent to angle B? All right, 180 degrees around my midpoint. So the angle doesn't change. Angle E is congruent to angle B. All right, I think I've labeled everything possible that I could. I hope that helps make sense of the question and the difference between a reflection and a rotation. Make sure in number 1 you read the directions carefully. Feel free to use tracing paper. And this problem here on the back, I'm going to pull a happy face by because I love it. Make sure when you explain your reasoning, you give me a convincing argument. All right? Thank you everybody so much. Remember, I'm on YouTube and TikTok now. Same handle, MacPhee and me. I go where my audience tells me to go. All right, I enjoy working with you every day, everybody. Thank you so much. See you soon. Bye.